Hey everyone, and welcome. Today, we're diving deep into something that powers our digital lives but often goes totally unnoticed: software reliability. And no, this isn't about some boring corporate policy. This is the actual playbook that the world's biggest and best digital services use to make sure they are always on, no matter what. So, let's get right into it. You ever just stop and wonder about that? You're binge watching a show, you're in the middle of some online shopping, and the service just works. It's always there, it's always fast. It almost feels like magic, right? How on earth do they pull that off when you hear about other sites crashing all the time? Well, here's the secret. It is not magic. Not even a little bit. It's the result of a very deliberate, very rigorous, and honestly, an incredibly smart plan. This kind of rock-solid reliability doesn't happen by accident. It comes from intentional design and a super strict set of rules that everybody has to live by. Okay, so to really get why this playbook is so critical, we gotta talk about what happens when things go wrong. See, when a system goes down, it's so much more than just a tech problem. It's money flying out the window, it's a huge hit to a company's reputation, and maybe worst of all, it's breaking the trust you have with your users. Every single second counts. So let's just make sure we're all on the same page with the key term here. When we say reliability, this is what we mean. It's the ability of a system to do what it's supposed to do correctly, without failing day after day. It's all about being predictable and consistent. All right, now this is where the whole mindset gets really fascinating. The philosophy behind truly reliable software is kind of backwards. You don't build it hoping everything will be perfect. No, you build it knowing that things are absolutely going to break. You designed for disaster right from the get-go. And here it is, the blueprint for that resilience. First up, graceful degradation. That just means if one small part fails, like say the recommendation engine, the main part, like the video player, keeps on working. Then you make services stateless. This simplifies things massively. You also build in redundancy, which is just having copies of everything in different places. So if one server in Virginia goes down, another one in Oregon is ready to pick up the slack instantly. And then you've got these other patterns, like being asynchronous to avoid traffic jams, and something called circuit breakers, which are so important they get their own slide. So, what is a circuit breaker? Seriously, just think about the one in your house. If you plug in a faulty toaster and it starts to draw too much power, a switch flips to stop your house from burning down. It's the exact same idea in software. If one little service is struggling and getting overwhelmed, the circuit breaker trips. It automatically stops sending traffic to that one broken part, which gives it time to recover and, more importantly, prevents it from dragging the whole system down with it. It's a lifesaver. So you've got this amazing, disaster-proof design. Great, but how do you actually update it? How do you add new features without shutting everything down for maintenance in the middle of the night? Well, that's what this is all about, shipping new code without being terrified. And wow, this slide really shows the difference. The old way was these nightmare big bang releases. You'd push months of work all at once, cross your fingers, and just pray nothing broke. The new way? It's the total opposite. We're talking small, constant, automated updates that have almost zero risk and happen without anyone ever noticing. No downtime. And one of the coolest ways they do that is with something called a blue-green deployment. It's so smart. Look, you've got your live version. We'll call it blue. Now, behind the scenes, you deploy the new code to an identical setup. We'll call that green. Once you've tested green and you know it's solid, you just flip a switch. Instantly, all the users are now on the green version. And the best part? Blue is still there, ready to be switched back to in a second if anything goes wrong. Seamless. But that's not all. The safety net has way more layers. You can use feature flags, which let you deploy code that's turned off by default, and then you can switch it on for users later. Of course, tons of automated tests have to pass before anything even thinks about going live. And if a deployment still somehow fails, the system is smart enough to automatically roll itself back to the last working version. It's all about minimizing risk. Okay, so the system's live, it's updated. How do you make sure it stays healthy? This is where things get really futuristic. Modern systems can watch themselves, learn from what they see, and in a lot of cases, they can actually heal themselves. It all comes down to these three pillars of what we call observability. First, you have metrics. They answer the big question, are we healthy? They're tracking speed, error rates, stuff like that. Then you have tracing. This answers, where is the problem? It follows a single request as it weaves its way through the entire system. And finally, logs. They answer, why did it fail? By giving you a super detailed, line-by-line story of exactly what happened.
And to make sure all these safety systems actually work, teams do something that sounds completely nuts. Chaos testing. Yep, it's exactly what it sounds like. You intentionally break things on purpose in a controlled way. Think of it like a fire drill for your software. By causing a little controlled chaos, you find all the hidden weak spots before they have a chance to cause a real disaster for your users.
And the foundation for all of this is a concept called infrastructure as code. So instead of a human manually clicking buttons to set up a server, you write code that describes your entire system. The key takeaway here is that it makes everything automated, perfectly repeatable, and it gets rid of human error. You can literally rebuild your entire operation perfectly just by running a script. It's a game changer. Look, we've talked a ton about architecture, code, and operations. But you know what? None of it works without the most important part, the people. And this playbook makes one thing crystal clear. Reliability is not just some engineer's problem. It's everyone's job. It is a team sport through and through.
And that shared responsibility is spelled out. The CTO owns the whole strategy. The dev teams, well, they have to build reliable code that meets the standards. The DevOps and infrastructure folks are the ones automating everything and keeping the foundation strong. And even the security team plays a huge part, protecting the system from attacks. See? Everyone has a role.
And let me tell you, this policy has real teeth. If a team doesn't follow these rules, they can literally be blocked from shipping new features. For really serious issues, things can get escalated all the way up to the CIO or even the board. So yeah, these are not just friendly suggestions. They are hard and fast rules to make sure the whole company is obsessed with reliability. And that really brings us to the most powerful idea in this whole playbook. Reliability isn't just one more thing on a checklist you do at the end. It's not a nice to have. It is the most important feature. Because if the service is down, none of your other cool features matter at all. So what we've really looked at here isn't just a technical guide. It's a blueprint for building trust with millions of people. It's what separates a decent digital service from one that people can truly deeply depend on. So the only question left is your organization ready to build it? Thanks so much for joining me.